Hello student. Hello student. How are you? I am Arunsir. Welcome to my channel Tuition Expert. Today in this class, I'll teach you some important problem on the chapter friction. Student, if you watch my video regularly and follow my class attentively, then I can assure you that you must crack the iitjee exam and NEET confidently with a good rank. Now let's start about the class. Here two problems are given. So now notice this problem. Now what is the problem here? A 5 kg block is placed on a table and two strings. These strings and these strings. This 15 kg block is attached with these strings and 5 kg block is attached with these strings. Two strings are separate. That is two different strings, not same string. Find the tension in the strings. If the system is released, find the tension in the strings. You have to find the free body diagram. You have to draw the free body diagram. So what is 5 kg in 5 kg block? What is the forces? The forces is tension T1. Suppose this tension is T2 and 15 kg block 15 into G 10 T1 and 5 kg block 5 into 10 and this is T2, and suppose the whole system accelerate in this direction because this weight is more, so the whole system accelerate in this direction. Acceleration is suppose A, so this 5 kg block moves in this direction A and this accelerate in this direction. Suppose whole the system will accelerate whole the system will accelerate in this system in this way. Okay, this way, this. Now what is the friction acting on this block? Friction will be friction if the block moves in this direction, friction act in this direction. What is friction? Friction equal to mu mg. Mu equal to 0.2 m5 into g, that is 10 Newton. So friction acts on the 5 kg block is 10 Newton in this direction. Now write the equation of motion for each block. First this block equation of motion will be 150 minus T1 equal to ma 15 into a. So this is the equation of motion for 15 kg block. This is 15. Now equation of motion of this 5 kg block. T1 in this direction, because the acceleration is in this direction, T1 minus opposite force is 10 Newton and T2. 10 minus T2 equal to ma 5 into a. This is equation for 5 kg blocks which is placed on the table, and for this 5 kg block what is the equation? Equation is T2 minus 50 equal to 5 into a. Now add this, so T1 cancel, T2 is cancel. So 150 minus 60, that is 90 equal to ma 10 25a. So a equal to 90 divided by 25, which is 18 by 5 meter per second square. Okay, so acceleration we got 18 by 5. Now to find the tension, just put here acceleration, value of acceleration put here, we get T2, and from this equation we get T1. We get T1 equal to 150 minus 15 into a, which is equal to 15 into 18 by 5, 54, 150 minus 54, 6, 90. So T1 is 96 Newton. This is T1 is 96 Newton. Now what is T2? From 2 we get T2 equal to 50 plus 5a, a equal to 18 by 5, which is equal to 50 plus, so T2 equal to, from equation with T2 equal to 50 plus 5 into a equal to 18 by 5 cancel, so this equal to 8 plus 6, 68 Newton. So tension in this block is T2, which is 68 Newton. Okay, just write the three equation of this system. Whole blocks will move in this direction, so the acceleration, direction of acceleration I have shown in this direction, and the first write the equation of motion, then you get the first write the equation of motion for every block, you get the required value. Okay, this diagram, in this diagram 4 kg and 2 kg block, in this diagram 4 kg and 2 kg block, 4 kg and 2 kg block are placed side by side on an inclined plane. Coefficient of friction of the 2 kg block is mu1, coefficient of friction between 4 kg and block is mu2, inclination is 30 degree. Now calculate the acceleration of 2 kg block if mu1 equal to 0.2, mu2 equal to 0.3. This is for case first case, and if coefficient of friction is reversed, that is mu1 equal to 0.3, mu2 equal to this, find the also acceleration of 2 kg block. That is two question. First case given mu1. What is mu1? mu1 is the friction between 2 kg and the inclined plane. mu2 is that of 4 kg and inclined plane. And first case if mu1 equal to this, mu2 equal to this, find the acceleration of 2 kg block. And second case if coefficient of friction is reversed, that is this and this, what is the acceleration of 2 kg block. Now here two cases may be arised. First, if 4 kg and 2 kg block move separately, then this will be the if 4 kg and 2 kg block move separately, then free body diagram will be free body diagram is different if the two blocks move together. So if the two blocks move separately, then free body diagram one type, and if they move together, then free body diagram will be another type. So first we consider first we calculate two body move together or not. Two body move together or not. So first think that 4 kg and 2 kg blocks are separately moved. So what happens if 4 kg block is placed on the inclined plane? What is the defined force acting on the block? For here mg sin theta 4 into g sin 30 degree. Sin 30 degree is half, and here 4 kg block. So friction will act in this direction. What is the value of friction? Friction will be mu mg. So here for first case consider for first case, so mu equal to 0.1 here and mu equal to 0.3. So mu that is 0.3 into mg, that is 40 into g is 10, 40 degree equal to root 3 by 2, because for inclined plane what is the reaction force? For inclined plane we know if m is the mass of the block, so reaction is r, which is equal to mg cos theta, we know, and friction act in this direction, friction equal to mu into r mg cos theta. So we apply this formula, friction force equal to mu mg cos theta. So friction equal to mu mg cos 30 degree. So 2 cancel, 20 3 by 10, that is 3 by 10, that is 6 root 3. 6 root 3 means 6 into 1.732, which is equal to 10.392. Now what is the acceleration of the 4 kg block? Acceleration will be 20 minus 10.392 divided by mass 4, which is equal to roughly 20 10.392, that is 8 7 9 9. So 9.708 by 4, which is equal to something 2 this. So acceleration of the 4 kg block will be this. And what is the acceleration of 2 kg block? 2 kg block, for this case 2 kg weight mg sin theta 20 sin 30 degree half, and friction force equal to mu equal to 0.2, mu mg 20 into cos 30 degree root 3 by 2, that is 10 2 cancel, 10 2 by 10 2 root 3 2 root 3. So 2 root 3 means 2 into 1.732, that is 3.464. So 10 what is the acceleration of the block A2 will be A2 equal to 10 minus 6.3, this divided by mass equal to 2 kg by 2 kg, so 3.286. So acceleration of the 2 kg block is more than the acceleration of 4 kg block, this is the acceleration of 4 kg block, and this is the acceleration of 2 kg block. Now if they are, if the value of this and this is this, then 2 kg block will move fast than 4 kg block. That is, two blocks now move together, 2 kg block move together. Okay, now as the acceleration of 2 kg block is more than the acceleration of 4 kg block, this is a2 and this is a1, that is, acceleration of 2 kg block is more than acceleration of 4 kg block, then two block move together, two block. So for first case, two block move together. As the two block move together, what is the free body diagram? Block is greater than acceleration of 4 kg block, 4 kg block. So two blocks, move together, so two blocks move together. Now 2 kg block, this is 4 kg, 2 kg. So weight of the 4 kg blocks, mg sin 30, mg is 40, sin 30 is half, so 20 Newton act in this direction. Now weight of this block is mg 20 sin 30 degree, that is 20 into half, that is 10 Newton. Now this exert action which is denoted by r, this is action which is r, so the reverse reaction is r here. Now the acceleration a, as the two block move together, so acceleration becomes same. Now what is the equation of motion? Here equation is 20, and friction. Now friction is act in this direction. What is friction? Friction equal to mu mg cos theta. Mu equal to, what is mu? Mu equal to mu2. Mu2 equal to here 0.3. So 0.3 mg means 40 into cos 30 degree is root 3 by 2. Root 3 by 2. That is 10 to 6 root 3. 6 root 3. That is 6 into 1.732. That is 10.392. So 10.392 is the friction force. Now equation of motion of this is 20 minus 20 plus r act in this direction, 20 plus r act in this and opposite friction act in opposite direction. So this is equal to ma, m is 4 into a. So this is equation 1. Now for this equation here, friction force equal to what? Friction force F2 equal to, this is suppose F1, friction force equal to mg, mu equal to 0.2, mg equal to 20 cos 30 degree root 3 by 2. So this equal to 2 by 10, 2 root 3, so 2 cancel, 10, 0.2 means 1 by 10, 2 root 3, that is 2 into 1.732, 3.464, this Newton. So friction equal to this. Now the equation of motion of this block is 10 in this direction, r minus friction is 3.464. So this equal to ma, m equal to 2a. So this is the equation of motion, 20 plus r minus friction equal to ma, and here 10 minus r minus this equal to 2a. Now add this. So if we add 13.8656, 13.856, 4 to 6, I will see this. Now if we subtract 30.000 and 13.856, 4 6 4 9 1 6 1, so 16.144 equal to 6a. Now a equal to by 6, so in first case acceleration equal to 2.7 meter per second square. This is for first case acceleration of the both block 4 kg and 2 kg, both block acceleration will be 2.7 meter per second square. This is the answer. So first we calculate that two blocks move together. For that we calculate first acceleration of two blocks separately. Then if as 2 kg block, acceleration of 2 kg block greater than acceleration of 4 kg block, so we consider that two blocks move together, because if accelerate fast, then if the acceleration is more, then so it moves slowly, and it is fast, so at a time two blocks move together. So now consider two blocks move together, that is acceleration is same. Now what is the free body diagram? Free body diagram of 4 kg block is this: 20 Newton act in this direction, friction act in this direction, and it will exact a action force. The 2 kg block exact a action force. If this is action, then this is the reaction, and weight of this 2 kg blocks 10 Newton, and friction act in this direction. So now what is the equation of motion? Equation of motion is this plus this 20 plus r act in this direction, friction opposite direction. So 20 plus r minus friction equal to ma. Friction force we calculate here mu mg cos 30 degree, which we calculate this. Now for equation of motion of 2 kg block, what is 2 kg? 10 plus r 10 act in this direction, r and friction act in this direction. So 10 minus r minus friction equal to ma. Now add this, we get the acceleration. Now for second case, what 3 and mu2 equal to 0.2. So this is mu2 means 0.2. So friction force equal to friction force F1 equal to mu mg cos theta, that is mu equal to 2 by 10, mg equal to 40 into root 3 by 2. This is the friction force. 0 0 cancel, 2 2 cancel, 4 root 3, 1.732, which is this into. So here acceleration equal to 26.928 divided by pi. This is 4 kg block, so 4, which is equal to acceleration this divided by 4. Now what is this? This equal to 2 7 4 14.072 by 4. So this will be 3 point something. So we calculate 3 point something. Now what is the acceleration of 2 kg block? Calculate the acceleration of 2 kg block. A2 of 2 kg block. Now here 20 Newton act. Weight of the 2 kg block is 20 Newton. Friction F2 equal to mu mg. What is mu? Mu equal to mu1, that is 0.3. 3 by 10 mg 20 cos 30 degree root 3 by 2. So 2 to 3 root 3 means 3 into 5.196. So acceleration A2 equal to 20 minus 2 kg block. Here acceleration 20. Here acceleration equal to sin 30. That is mg sin 30 is 20 into half. 20 into half. That is 10 Newton. 10 Newton. So acceleration of A2 of 2 kg block is 10 5.196 divided by 2, which is equal to, what is the subtraction? Subtraction is 4 44904 divided by 2, that is 2 point something, 2.545. Now the acceleration of this block, that is A1 equal to 3.5, and acceleration of this block is 2.45. So now this block move faster. If this block move faster and this move slow, so two blocks separate after some time. So now the two block move separately. So first 4 kg is greater than acceleration of 2 kg. So two blocks moves. So two blocks moves separately. Now draw the free body diagram, and you can calculate the acceleration of each block. Now draw the free body diagram. What is the free body diagram? So for 40 into sin 30 half, that is 20 Newton act in this direction. Friction force act in this direction. What is the friction? Mu mg cos theta. Mu1, that is, this is mu1 mu2 equal to here 0.2 mg is 40 into cos theta root 3 by 2. 0.2 means 2 by 10. So acceleration A1 equal to this. So 2 kg for second case. So this is the acceleration of 2 kg block for second case. The next problem is here a board. This is a board placed on a ground, and the man is on the board, pulled the string shown in this diagram. Pull the string. This string is attached to the board. So if the man pull the string, then the board can move in this direction. So what is the question is, what is the maximum force that the man can exert on rope so that the board does not slip on the floor? this is a board, wooden board. Coefficient friction between board and the ground is mu. So find the maximum force, that the man can exert on rope so that the board does not slip on the floor. This is the question. So how can we solve this problem? And this is another question. First I discuss this problem. Now first we have to draw the free body diagram. First we have to draw the free body diagram, then we can apply the equilibrium condition. If the man exert the force on this direction, that is, suppose the man exerts the force F in this direction, so pull in this direction, so this is F, the force on the man will be F in this direction, upward direction. Now this force F, reverse F, so this is the force F act on the rope. The force act on the rope, direction is given here. Now due to this force, the board can move in this direction, so friction prevents the slipping. The friction equal to mu mg. Now what is the normal direction? So we have drawn now the friction. This is the friction. Now how we calculate the friction force? So this is the weight of the man, mg, and reaction force. Now this is a board. So here the reaction force act in this direction, and reaction force act in this direction. This is R. So R exert, the man exert the force on the board, which is R. So the opposite direction R act on the man. Weight always act through the center of gravity. So we place weight from the center of gravity, that is mg. Now what is the free body diagram of board? The board is here. Here a friction, here this force is comes, and friction is this. Now what is the reaction from the ground? Reaction from the ground is suppose R1. Reaction from the ground, suppose this is R1. Now weight of the board is mg. So now we draw the free body. We have drawn the free body diagram. Now balance the equation, balance the force. We get F plus R equal to mg. F plus R equal to mg. Okay. From this we get R equal to mg minus A. Now from this, what is the R1? Here R1 balance. R1 is the sum of R plus mg, sum of R plus small mg. Okay. Now what is the friction? Friction equal to mu. This is coefficient of friction is given mu into R1. Coefficient of friction is in this direction, which is mu into R1. That is mu into R1 means R plus mg. So this is friction, this is force. Now for equilibrium of the board, for equilibrium of board, F act in this direction, F equal to friction force, which is equal to mu R1. F equal to mu into R1. What is R1? R1 equal to friction force equal to this mu R1, that is mu into R plus mg. So F equal to mu into R. What is R? From R we get this R equal to mg minus F. So R equal to mg minus F plus small mg. From this we get F. So F 1 plus mu F, shift mu F in this direction. So this will be this plus, this will be plus, equal to mu into m plus small m into g. So F equal to, we get mu into m plus m into g divided by 1 plus mu. So this is the answer. This force, this is the maximum force. If we exert, then the board does not slip. So I repeat how we solve the problem. First, draw the free body diagram of each body. If the man exert the force F on the roof, then what comes? Exert the force. So if force F act on the man is placed on the board, the man is stand on the board, so a reaction comes from the board in this direction, weight of the man act in this direction through the center of gravity. Now as there is no motion along vertical direction, so A plus R balance the weight. From this we get R equal to this. Now if we consider the equilibrium of the board has no acceleration or movement along this direction, so this will be R plus mg. Here R, this is the action and this is the reaction. R comes from the contact between man and board. This is the contact force between man and board, and R1 is the contact force between board and ground. So R act in this direction, R act in this direction. Now from the contact between board and ground, R1 comes upward from the ground. So we don't draw, suppose this is the ground, so ground a reaction R1 stands, reaction R1. So this is not required, just we consider the motion equilibrium of the board. So R1 comes from the ground, and this is, if this is ground, so reaction R1 act on the ground. This is not required because we don't consider the motion of the ground, we consider the equilibrium of the board or motion of the board. So R1 act in this direction, R act in this direction, mg act in this direction. So for as there is no motion along vertical, so R1 will be R plus mg. Okay, so that's why you get R1 equal to this. Now for equilibrium of the board, here force is act in the direction, friction act in the direction. What is the friction force? Friction force will be mu into R1, which is equal to R plus mg. So for equilibrium of board, F act in this direction, friction equal to mu into R1. Now R1 mu into R1, that is mu into this. Now what is R? R equal to, from here we get mg minus F, R equal to mg minus F plus mg. So shift here, just you calculate, shift here, mu into F in this direction, so 1 plus mu, and mu into this plus this equal to this, mu into F act in this direction. So if F into 1 plus F plus mu F minus mu F in this direction, mu into mg minus mu F plus mu into small mg. Now mu F in this direction, 1 plus mu equal to mu g m plus m. So F equal to mu g m plus m divided by 1 plus mu. So this is the value of F. Now in this, what, here two blocks capital M and small m are placed one upon another, and two blocks are placed on the ground. Coefficient of friction between this block is mu by 2, and coefficient of friction between bigger block and the ground is mu. Now the system, what the question, the system is started towards right with an initial velocity v. The whole system start with an initial velocity v. Find the time elapsed before the smaller block separate from the bigger block. That is, two blocks move right side with an initial velocity v. Now small block m moves faster, then after some time the block separate from the block of mass capital A. If the distance covered by the block is S1, and if the distance covered block by the capital M is S2, then the block M separate from the capital M if the distance covered by S1 equal to S2 plus L. Now what is the acceleration of each block? Suppose first we find the retardation. For M, the friction force act in this direction, which is equal to mu to mg. So this will retard, the retardation will be m into a1 equal to mu by 2 mg. So a1 equal to mu by 2 g. So this is the retardation. And for block M, this is action, then this will be the reaction, because we know for every contact surface action and reaction is opposite, mu by 2 mg in this direction, and here friction is mu into m plus m into g. So for block M2, what is the retardation? Retardation will be mu into m plus m g minus mu by 2 mg equal to m a2, suppose a2. Now what is a2? Mu mu g common, m plus m minus m by 2 equal to m into a2. So a2 equal to mu g 2m minus m, that is m plus 2m divided by m by 2m mu g m 2m plus m minus m, that is m plus 2m by 2m by 2m. This is the acceleration of a2. Now what is the a2? So what is the retardation? Retardation is this. Now equation of motion is s1 equal to s2 plus l. So right here, so just we can write here the acceleration of a1 equal to mu g by 2, and acceleration of, this is retardation, so retardation equal to this, and retardation of capital M is this, mu g by 2m. Now put here s1 equal to what? S1 equal to Vt minus half a1 mu g t square. S2, what is S2? S2 equal to Vt plus minus ut minus half a t square, minus half a2. A2 is equal to this mu g by m plus 2m by 2m into t square equal plus l. So Vt cancel. Now take common this mu g t square by 4. If you take common mu g t square by 4, what comes? M plus 2m by 2m minus 1. This is 1. M plus 2m by 4 common m. So this equal to L. Now m plus 2m minus m plus m divided by m equal to 4L mu g. So t square equal to 4L. So mu g t square 4m, m plus m equal to L. So t square equal to 4m L by mu g into m plus capital M. So t equal to root over 4 ml by mu g into m plus capital M. So this is the answer.